And if I want a two column, you can add a two column document here. Or if it is by default, it will be one column. If you want a two column, you can make. And you always in the preamble also contains some packages, whatever are the things that you want to add in the document, the suitable packages should be included. So the markup command to include the packages is /use package. If I have a mathematical terms, AMS math, these are default for anything, these things should be there. AMS math, and one of the important packages AMS symbol, AMS symbol, and some graphics packages as required if you are importing any images, graphics, then slash package. If you want to make spacing like double space, single space, you want to use set space package. Now, today, apart from whatever we have discussed yesterday, I will also explain you how to write the equations, import algorithms, tables, and all today. So let us consider this as the basic packages. Now, once you have completed your preamble, you have to choose your title. Even title is also a part of the preamble, or you can also make it as a part of front matter, anything as per your choice. Yeah, title. So the second day, or the art of drafting. That is the title. Author, drafter. So now I have completed the preamble part. Now if you want to start the documentation, /begin. Begin the document /begin document and /end document. First, whatever the title and whatever the author name I have created, let me add it in the document. The command to use is make title. If I run this, the title and the author along with the date will be displayed as a part of the French method. Now, once the title is made, we can make different sections. Let the section, if to create a section, the command is /section. Let me have a fast recap what we have done yesterday. So this is a introduction section. Okay. And under this introduction section, we can have a paragraph or something like this. To have some garbage paragraph, the command is lipsum. If you want to use the lipsum command, you want to include the lipsum package. Now the command to have a paragraph in the introduction is /lipsum. Let me have one paragraph. Now let me run this document. The output shows as it is a two column. I have created a two column document here. So if I just remove this two column, it will be a single column document. So it is by default, it will be a single column document. If you place a two column, then it will be a two column document. Similarly, if I want to make some subsection under the introduction subsection, this is let the subsection is related to some spacing or alignment, something like this. And under this alignment, if I have some text like the art of patent drafting, this can be aligned by default towards the left. But if you want the center alignment, the commands are like center. And if you paste it, this is the center alignment. And if you want to have left side alignment /begin, because by default, all the commands are shown here, /begin, flush left, the art of patenting. This will be moved towards left, and /begin, flush right, /begin, flush right. So if I just run this document, the output will be like the 1.1 section is related to alignment. By default, it is left side aligned. If you want to make center alignment, you can use begin center. And this is flush left means towards the left and flush right means towards the right. So similarly, there is one more thing. If you want to have one more subsection slash sub section, if this is related to some items or listing, how can you do this? There are some commands like slash begin itemize, okay, and whatever you want to make as a bullet point, you can just use slash item, and it will be visible as bullet points. You just check it. So the listing is a subsection under the introduction. So, and I'm just using, I'm just listing out the points by using the command slash begin itemize. If I want to number the points, the command is like slash begin. Right. So here, this is the first line and slash item, second line. So this will give you a number before the lines rather than bullets. Let me run this. Okay, this is how it looks like. And yesterday we also discussed that in section. Let me create a new section. Symbols should not be used. What are the symbols we should not directly use? Not to be used. So here symbols like dollar, percentage, open flower brackets. These things cannot be directly used. All these symbols should be used followed by a hash. These should be preceded by hash. Then only those symbols will be printed in the PDF document. Okay. Apart from that, we have also discussed how to add the footnotes and how to change the fonts and all. To add a footnote, the command is just footnote. So these symbols to be preceded by backslash. Okay, if you just run this, okay, let me just try. Okay, here this should not be the here this should not be the backslash. So here the footnote number is given, and at the bottom the footnote will be present. Apart from this, yesterday we have discussed how to make how to change the font into bold, italics, and underline. Just if I want to make it as bold, just to press Ctrl B, or you can use the command text BF, and this will become bold. You can check it. This is the footnote. And if I want this text to be in italics, Ctrl I, or you can use /emph. So then it will be both bold and also it is in italics. So this is how, and if to make it into an underline is /underline. Underline is the command for this. Then if I add all together, this text will be in this text is in bold, italics, and is also underlined. This is how you can make, and even you can change the font. By default, the footnote will be a footnote size. If you want to make it huge, you can make also huge. Let me check whether it will be applied for a footnote or not. Yeah, it is applied. So even the font is huge here. Like that, there are different type of standard fonts coming from tiny, script size, small, normal size, large, with capital L, the large word in caps, then huge, and a huge word with the starting letters capital. Yesterday I have shown, and I also have shared the text document with you. Just so you can have any standard font as per your wish. Apart from this, yesterday we also have discussed how to add the figures. Let me for figures. You can add the figure by using an figure environment slash begin figure. So to include a figure, the command is slash include a figure. Just you choose an option like this, where you can choose the width as the line width, the width as slash line width, comma keep aspect ratio. So it will keep the aspect ratio of the figure. So then you can give the name of the file. Before that, let me save this file in the same folder which I have done where I have saved before. Let me save demo 2. Okay. So here there are some files. JP. Let me just check which file is that. Yeah, jpg dot jpg.eps file, and if I run this, the figure will be included. So actually, the figure should be in the section 3, but it is placed by default on the top of the paper. So if I want exactly before the section 3, I can use some arguments like ht that will place the figure exactly at where we have created the figure environment. And you can choose the width of that as 0.5 line width, means the figure will be of any size. And in this figure environment, you can use different markup commands to make it center. Slash centering makes the figure as center, and you can even give a caption to the figure using the command caption, my first figure. And even you can use label to give cross-referencing. So this is figure 1. So all these things are, why is this labeling? For example, if I want to describe, this is my figure, figure slash, if I want to refer to that figure slash ref figure 1. If I do so, automatically the whatever the label, whatever the figure number is there, it comes here. Just check how it works, how it looks like. So this is how adding the figures and cross-referencing the figures. Apart from that, yesterday, I think this is a brief summary of what we have discussed in yesterday's session. Today's session, I will be exclusively discussing about how to write the equations and how to add the tables and how to add macro shortcuts in Text Studio software, and how to add algorithms and how to add the bibliography, how to reference with some articles. So I will stick on to these points in today's session, and I will also show you what are what are the things that can be done beyond just with the documentation using the LATEX. So let me open a new section. So mathematical equations. By default, there is a inbuilt grammar checking in Text Studio software. So let me open the mathematical equations. So here, let me just create a new page. We can create a new page by using a command called page break. Okay, so I run this. The mathematical, that is the section 4, will be available in a new page. Now, how to write the mathematical equations? First, let me just give you a standard notation. Whatever you want to write as a superscript, you just use the cap symbol. Whatever you want to write as a subscript, you just use the underscore. And as mathematical equations, it can be either inline equations, either inline, let me just make into a list slash begin, itemize. It can be inline equations, or it may be separate equations. Right? Equations. So first of all, let us discuss about the inline equations. For example, I want to write the equation of a circle. So I'm writing the equation of a circle. is whenever you're writing an inline equation means the equation will be a part of the sentence. So equation of the circle, as everyone knows, that it is x square plus y square is equal to 1. Just give me a minute. Sorry. So if you want to write any inline equations, the inline equation should be in between $2. That's why you can't use this dollar symbol directly as a part of the text in LaTeX. If you want to use this as a part of the text, you have to use this backslash symbol. But by default, if you have $2 symbol, in between, if you write the equation, then it will be treated as an inline equation. I will show you. So from this, let me make the font as /large just for visibility from section 4 onwards. Equation of the circle is x square. So I can write x as a normal thing. The 2 will be in the superscript. As I said, whatever is the superscript, it should be given by a cap, and you have to write 2. This means x square. Plus is normal, and y, again, the y square means the 2 will be the superscript. Square is equal to 1. If I run this, you can check how beautifully the equations are made in LaTeX. You can see here. So the font is in the large font, and I have created a beautiful inline equation, which equations are generally italics. So x square plus y square equal to 1. For example, if I want to make an equation like x square plus y square equal to z1 where z1 is in the subscript, as I said, z. Okay, and if you want to make anything in the subscript, you just give an underscore followed by the number z1. If I run this, you can check z, and the 1 is in the subscript. Okay, let me make the font as huge. So these type of equations are called as inline equations. So, and if I want to write some other equation as the other equation is x square plus y square. Okay, our integral x square dx is equal to integral x square dx, just for simplicity. Just again, it is an inline equation. If you want to write an inline equation, you just use $2. I want an integration. One thing who are new to this LaTeX, you can find all these symbols here. So you just go to the symbols here. So all the different type of symbols are available. So if you want any operators, you just scroll down here, integration. If you just place your cursor, it will show you the command. The command is /in. Or if you want any product symbol, the command is /prod. If you want a union symbol, the command is /big curve. There are each and every commands. If you don't remember the command, you can explore the symbols here. Not only the symbols, you can have different operators, different Greek symbols, like alpha, beta, gamma, and many things, and different type of math symbols. Okay, different things will be available here. So now what is the what I have said? I want to make an inline equation, and the equation is /int. It is an integration of x square. X cap 2 is called as x square dx. If I compile this, you can check the other equation is integral x square dx. So this is how you can write the equations in the inline equations in LaTeX. But sometimes we need to have equations as a separate part of the text, and it should be numbered like 1, 2, 3, and so on. In such cases, you can write separate equations by just opening the equation environment /begin equation, and let me write the same equation. The first equation, I want to make the equation of the circle. or a simple equation like x squared plus y squared equal to 1, which is a circle equation. X cap 2 is called as x square plus y cap 2 is called as y square is equal to 1. Now, if I run this, you can feel the difference. What actually is the inline equation and what is a separate equation? See here, the inline equations by default, they are not numbered. They are the part of the sentence. But an equation which is written in between the equation environment by using the command /begin equation and /end equation, the equations are by default, they are at the center followed by an equation number. And even you can give a label to this equation like a slash label. Let me EQ1, that is a label for this equation. Okay. Now, if I want to use this equation, I can just cross-refer the equation. The equation below represents a circle or I can write like the equation 1. Okay. The equation. So what is the number of the equation? It is not always advisable to use the static numbers because sometimes you may be rearranging the equations. That's why the label and cross-referencing helps. /ref, and what is the label I have given? Equation 1, right? So if I do so, and if I run this, by default, this cross-referencing yields to this number. And you can even check it here. The equation 1. So this is how by default the equation comes. Okay. And there is one more command. I think it will not, I don't know whether it will work, especially for equation referencing. There is a command called as EQRef. If you write EQRef, you see here there is no brackets for 1. But if you write EQRef, automatically, this is a standard format how we cross-refer the equations. General /ref is general cross-referencing, and /eqref is for equation cross-referencing. I hope you are understanding. Now let us see some other cases. I want to make one more equation which I had given before, /begin as a separate /begin equation. Integral. This is the symbol for integration. If you want to have a limits for integration, it shows us a option. The lower limit is 0 and the upper limit is infinity. Don't bother, infinity is a symbol. Whatever the symbol is there, they are being just adapted by its name, /ins. I think this is infinity. Let us check. There are two things that are available. One is infty, ins. Let us check, just do some try. Inf. What is the equation? X square, x cap 2 dx. So if I run this, I will get a separate equation, which is called as 0 to INF, but actually it should not be INF. It should be infinity symbol. So I should not use /INF. It is /INFTY, I think. Now let me run. Yes, 0 to infinity x square dx. This is the equation 2. Even you can give a label for this equation. If you don't know, as I said, if you don't know what is the command for that symbol, just go to the symbol and explore what are the different type of things available here. As the time progresses, almost you can remember everything. And by one beautiful thing with this text studio software is, if you just type some words related to your content, it will show some commands by default. So this is how we can write an equation. Now let us try to explore a bit more. For example, if I want to write the equation, which is the roots of a quadratic expression. I hope you remember it is -b plus or minus square root of b square minus 4ac by 2. Let us try to write that equation as a separate equation /begin. Sorry, /begin equation roots equal to. First, actually, it has the roots of the formula -b plus or minus square root of b square minus 4ac divided by 2a has two parts. It's a fraction basically. First, we want to have a fraction /f or a c. If you just type this, it will show you. I think the command is popping like this. You just give an enter. It has two parts. One is the numerator and the other one is the denominator. Let us fill the denominator. You know that the denominator is 2a, right? And in the numerator, it is -b plus or minus. I don't know what is actually the command for plus or minus. Let me just explore it. I'm just clicking on the symbols. I want to go to the operators. Yeah, here it is there. The command is /pm. Okay, slash pm is the command. That is minus b plus or minus square root of. I think the slash sqrt is the square root. In the square root, it should be b square minus 4ac. So b square means b cap 2 minus 4ac. Check how it works. Yeah, see, this is the roots equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this is how beautifully the equations work in LaTeX. Now let me extend you something. For example, I'm writing an again. I'm writing an other inline equation as follows. So I want to write x power 2a. That is, I'm just opening an inline environment. X power 2a, and this 2a should be the superscript of x. That's what my intention. Okay. If I run this, you can check what is actually the problem in LaTeX. See here, I'm writing another inline equation as follows. But actually, what my equation is x power 2a. But here, whatever is the first term after the cap, that is only being superscripted, but a is not in the superscript. To avoid such things, it is always advisable. Whatever you want in the superscript or in the subscript, that should be entirely in the flower brackets. If I do so, whatever is in the flower brackets that is preceded by a cap, everything comes to the superscript. Now you can see the 2a is in superscript here. Similarly, for the subscript, if I want to make a subscript, x underscore, if I just write like my name Mahesh, only the m will be in the subscript of x, but the remaining will not be. But if I want that, I think you can see that m is only in the subscript, the remaining letters are not in the subscript. But if I want the entire thing is in the subscript to be in the subscript, I should make them in the flower brackets. Now you can see that my name entirely is the subscript of x. This is one important caution. Is there any doubts up to this point? Any doubts? Okay, now let me just extend this topic. Even though LaTeX is a very beautiful professional document making software, sometimes if you want to use the equations in Word, it's really complicated to use equations in Word. In my perspective, I don't know how about others. Let me show you a smart way of writing equations in Microsoft Word. See, you can also write the same LaTeX equation in Word, right? Let me write the equation of a circle. X cap 2 plus y cap 2 is equal to 1 followed by a dollar. Now this is a general LaTeX equation. If you install a math type software, there is something called as toggle text. If you just click on this toggle text, it is taking a while. See how the equation came into picture. Okay, like this, it is always advisable to write the equations in LaTeX. Similarly, I'm writing one more equation slash int, which is the integral, and the lower limit is 0, and the upper limit is slash infty. Okay, and followed by x cap 2 dx. If I just compile this equation and toggle the text, you can see it is 0 to infinity x squared dx. This is a beautiful way of writing equations even in the Word, but by using the LaTeX markup commands. But if you want to do that in the Word, the math type should be installed in your system, else it may not be possible. So by using just the LaTeX, it will be so easy to write any complicated equations by just knowing the markup command. So I think with this, I can conclude my talk on this equations part. If you have any doubts at this point of time, you can ask me. Any doubts? So if you have any doubts at this point, you can ask me. Thank you. Now let us extend our topic. Just a minute. Let us just extend our topic to tables. Let me create a new section. I hope you got some information about equations and how to do it in LaTeX and how to cross-ref equations and all. Let us spend some time on how to make tables in LaTeX. Slash section, creating tables. Frankly speaking, I'm not quite an expert in doing the tables directly in LaTeX, but how we are habituated, especially how I'm habituated to make tables in LaTeX is there are some third-party tools by which you can directly create tables with ease. But what I have here is creating tables just from scratch will be a bit difficult, which I personally feel. So there are some third-party tools. I will show you a short demo. There is a website called as tablegenerator.com. Okay, so if you just go to this website, you can make your own table in LaTeX. There are different tools in which you want. You can use the same website, but I want tables for the LaTeX. I want a new table. You can just create as many rows and columns you want, as how you do in Microsoft Word. But these tables are in LaTeX environment. So this is a serial number, and this is the name. And this is the name, and this is the signature. This is the one. My name is Mahesh, and this is two, and my colleague is Nanda. So if you just write, if you just fill the table, and you can make the borders as you wish. So here you can explore whether do you want all these things to be bold or italics or underlined, anything you can make, and whether to be left aligned or center similarly. And if you want the borders for all the tables, you can just click this. You can just select, and you can make the borders for all the tables. Or if you want to clear the borders, you can make, and you can even merge. For example, if I want to merge these two, select and merge, it is merged. And if I want to center it, it is centered. Okay, and Control Z is basically the undo. And if you want to make the borders by yourself, I can just click on this select borders. I can just select what are the borders I want. I need only these borders, not all. Anyway, you can choose. You can design your own tables here. Okay. Once you have designed your own table, just click on the generate. Okay. So at the bottom, the LaTeX code will be automatically developed. You just copy this LaTeX code for table environment and go to your text LaTeX file, and you just paste it here. So this is how you can simply create a table. And you know that these are the arguments where you want to place the table. I want to place exactly below the section. So I'm using an argument /ht. If you want to make it as a top, it is just a T, or B for bottom, or HT for the place where you want to make it. Okay. If I run this, before that, let me just make the normal font because I'm using the huge font. Let me make the font as a normal size. Now, if I run this, see, you see the table is placed somewhere here. Okay, but if you want this table, because any table will be at the center of the page, it also has some caption. The same things you can make like that. After this table environment, you can just give a command centering. This makes the table at the center. And if you want to have a caption for this /caption, my first table, right? And even you can have a label for this /label tab 1. This is the, and if I run this, you can see the difference. See, the table is at the center of the page, because as there isn't any space, it is being placed at the mid of the page. But if the content is there, for example, if I make a /page break, and if I have some text here /lipsum, it will be in a different way. So I have created a new page here by using page break, and I have added one paragraph in this section. So just, I think I should add the paragraph after the font, because after this I will get a normal font. So now you see that the table is exactly placed after this paragraph by using this, or because as this is the argument which says to place the table before this paragraph, the table is exactly placed here. Okay, so this is how we can make the tables in LaTeX environment. It is no need to, because there are multiple things to be done here. My personal choice is to use this type of thought and tools like table generator. I think there is one more website, LaTeX tables, LaTeX table generator. Yeah, latextables.com. So you can also use this. Most probably I will be using tablesgenerator.com, but sometimes I will also use latextables.com. It's up to your choice. This is how you can simply make tables without any complexity. And even if you want to edit it further, you can save these tables in a separate file so that you can load it back. And if you want any modifications, you can do. Actually, even you can embed the figures or the equation environment even in the tables also. For example, here, if I want to write an equation here, it should be in inline equations always. It is not a beacon equation. So /int x square dx. If I generate this table and if I copy to the clipboard and if I paste it here, let me just copy the tabular environment only. And if I just replace it, and the equations can be a part of the tables. That's what I would like to say. Yeah, see, the equation is a part of the table. Like this, you can either include figures, even the figures, you can include the tables, even you can make the equations as figures. Anything can be possible. You can do experimentation by yourself. So with this, we have completed the equations and also the tables. Now I would like to extend the topic to how to write algorithms in LaTeX. So let me open a new section. Algorithms. So in order to write the algorithms, you should have a package, because the tables and all are by default, it will come. If you want to have if you want to write some algorithms, you should use the packages like algorithm, and there is one more package called as algorithmic. So these two packages are required in order to write the algorithms. So I have already a sample algorithm for you, which you can easily understand. Let me directly paste it here so that you can understand it. So let me create a new page. I'm breaking the page here. I have run. Yeah, you can see a beautiful algorithm is placed. Let us just discuss what actually is this. I have written the algorithm in algorithm environment, where the algorithm is placed in algorithmic environment. These two should be there. That's why I have included two packages here. One is algorithm package and the other one is the algorithmic package. Why two means the algorithm package gives a shape like this. That is the algorithm one priority assignment that will be placed in two lines because of the algorithm package, and the commands like for and so on, what are written here, those are all the part of algorithmic package. Okay. Let us try to understand what I have written here. You can easily, I have given a caption and I have given a label for cross-referencing. How to cross-reference /ref you can use to cross-refer this algorithm. Now the main algorithm starts from /begin algorithmic. Here the first line is for each device do. For whatever is in the maroon color, the red color, all these are the part of the LaTeX commands, that is markup commands. And for it has a specified format. Whatever you write, it is actually the part of the for. And whenever you open the for, it should be ended by using the command /end for. And in between them, if you want to write any statements, you have to write by using a command called a /state. Then you see there is a proper indentation and there is a proper format here. The for, and for, do, and all are in bold, which are the commands. And each device, which is a part of the for, and the statement which is e of t of n, which is equal to en of t, that is a statement. Everything is perfectly indented and it is in a proper way. Similarly, whenever you want to write the statements, use state. Again, I'm using one more for with some statements. You can similarly use if statements are not here. You can use if, while, anything you want. Just if you want to explore about algorithms, just you can Google it. There are a huge number of resources how to write algorithms and all. If you don't find any command, just Google it. Immediately you can find as per your wish. So I don't want to extend too much into the algorithm because it is not part. Generally, you know that algorithms and all are not patentable. Most of algorithms we write for academic writing, but if you write algorithm for a patent document, it is not good because algorithms, softwares, programs are not patentable in India. So with this, I will conclude with the algorithmic part. Now, finally, the bibliography, how to give proper citations, how to give referencing in LaTeX. To organize your references, I personally suggest you a software called ZebRef. So this ZebRef is a open source software. You can download it. Let me open a ZebRef here. I have already installed. You can download and it is already installed. Just see while it's opening. So whenever you want to cite some articles, for example, let me just open an IEEE Explore website. Let me just give you like Internet of Things. I need some articles that should be cited in my work. To do so, just let me click on any one of the article. Okay. And here you can just find an option called as cite this. Even for any journal, you can find this. Go to the BibTeX. BibTeX is a text format for bibliography or referencing. You just copy this and go back to the text studio because you are you want all the references to be in a document, not here in the main LaTeX document. Let me create a separate document. Let me paste it here because this is a bibliography. Bibliography means a set of references. Similarly, and here the key, that is the key to use this reference. Let me make it as ref1. Let me copy, let me use one more article also, a different article. So let me just open this and copy the BibTeX of this document. So to cite this BibTeX, copy, and let me paste it in a, new line, and let me name this as ref2. Okay. So these are like this, as many articles that you want to use in your documentation, you can add one by one in this document and make sure that this document is saved as a .bib extension, because it's a bibliography document, that is, it consists of a collection of references. So let me save it as a ref.bib. Then this is a bibliography document. Even if you run this, it won't work just like that, because it is not a part of LaTeX. It is a separate supporting document for LaTeX. Now, once you have a set of references separately saved as a bib file, now you can just go here, because always you know that the back matter, that is the last part of your document, is the reference. So there are two commands. One is bibliography. Okay, this is the bibliography. By using this command, you can import this file. What is the name of the file? Ref.bib, but no need to give the extension of this ref. And you know that for every article, there is a style. There is a style of referencing. But as we are electronics and communication engineers, which if you want to submit to an IEEE journal, we use IEEE format, IEEE style of referencing. So the bibliography style, there is a command like bibliography style, and let me just type like IEEE trad style, which I want to use. Or if you don't want to use any style unsort, this gives the default style of referencing. Now, if I just run this, check what will happen. So just automatically a section came as references, but there are no references, because we have the list of references under this name RES, but we have never cited them. How to cite? So /section. Let me create a new section for citing. Okay, let me create a new page. So if I want to cite, generally, how do you cite? Whenever you're writing, when you're writing some part, some text, in between, you will appropriately cite a document related to your content, right? So I'm writing a document on IoT. So IoT is a emerging thing, emerging technology. Okay, and if I want to cite this, already I have two references here, like the key reference 1 and reference 2. But if this line is a part of reference 1, I can cite by using command /cite. Automatically it comes what is the key ref1, right? With this, if I cite and other IoT technologies, just I'm writing something randomly like this. And if I want to insert a reference here, again it is /cite reference 2. This is how we can insert the references. Now check the magic. What happens if you compile this code, if you compile this document? So a new the page is being break and the section is citing. It is just still compiling. Now you see automatically, let me just increase the font to huge. Now, if you see, I'm a document, something I have written, and wherever the site is there, an appropriate citation is being placed. That is 1, 2, and are placed, and the same citations are also being placed under the reference section, where the reference section is being created by these two commands. And whatever the references that you have and whatever you cite in your document, all the references will be placed at the back end. That is at the last of your document. So this is how we can make referencing in LaTeX software or a LaTeX document. So if you have any doubts, you can ask me now at this point. Fine. Okay, finally, whenever you are writing a document, always for every environment like equation, figures, something sections or document, it is very difficult to use the commands always. So this Text Studio offers a option called as macros. You can make your own commands here. Just if you just type your command, I'm not just giving in detail about this macros. You can just create your own shortcut. Then if you, for example, if I created a shortcut to begin figure, if I write BF5, the complete figure environment will be coming there. So that is how we can use macros here. So, but I'm not going in detail because that is a part of the text studio. It is not part of the LaTeX. It depends upon the software to software. So with this, I hope that I have touched almost all the concepts, all the key things that are required to make a professional document. So if you see the document now, if you see the document now, I think the document is very beautifully typeset as per your specification. It has some sections, it has some subsections, it has some figures with the different fonts as per your choice, and some mathematical equations with different fonts, and some tables as per your wish, and the algorithms part. And we can also cite with the proper references. I hope you know that why all these things are huge, because that is my choice. I have used the command /huge. So this is how beautifully you can typeset a proper document using LaTeX. This can be either applied for an academic journals, or also even you can do it more beautiful for patent documentation also, which will be covered by my friend Mr. Sai Srinivas tomorrow, hopefully. So finally, let me show you some case studies which I have done before. It is not about just creating some professional documents. Even you can create wedding cards, certificates, brochures, whatnot. LaTeX is not limited to anything. Let me just show you some case studies which I have done before. Just give me a while. So this file is an invitation that I have made long back. Let me just run and show you how it is. It's taking a while because it contains figures of higher resolution. That's why it is taking too much time. Let me just go through this in a brief way. This is how the invitation that looks, which is being prepared in LaTeX. See how beautifully everything, the spacing, the font, and the organization is in a very beautiful way. It is loaded very slowly because the contents that are available in it are a high resolution of bigger size. The file size of images and all are bigger size. That's why it is being loaded slowly. But if it comes into a document format, this looks more professional. Similarly, these kind of things, you can also make some wedding cards. This is how we can make some invitation cards in LaTeX. Similarly, we have prepared for this art of patenting and drafting, we have prepared the brochure in LaTeX. Let me show you that. So this is the brochure of our workshop, which is being created using LaTeX. So this is the brochure that is being created in LaTeX, and you see the quality of this. It takes some time to adjust. See, it is everything is very proper. All the contents are vector images. Let me just go through this quickly so that you can easily understand, because it contains several pages. I have written, because see here, this is the document class, which is a leaflet of 3 columns. and it's a A3 size with 12 points. And I have used different packages which are necessary for this preparation of the brochure. And I have used a few commands that are useful to change the colors, that are used to insert the logos and all. Now, you know that the document starts from here, right? One thing I forgot to say, see, the LaTeX document even can be done. Even you can import any text files by using a command called as /import. So here I am importing one.txt. Just let me open this one.txt. This is the one.txt file, which I have been importing by using this command. Because if I write everything here, it will be looking clumsy. That's why I have created different documents, and I have incorporated in the main document here. Now, what actually is in one.txt means, you know, the first page of the document is online mode, a 5-day workshop, the art of patenting, then some images. That is what written here. I'm using a title, a online mode, a 5-day workshop, and the art of patenting and drafting. If you see here, it is in calligraphy font. I'm using a calligraphy font for that. Now, begin center, I'm including some image related to the patent. Then after some spacing, I'm including the dates here. Again, after some spacing, everything is centered. So I'm writing organized by Department of EC. Then I'm having the image of the college, followed by the logo of the college. This is the logo of the college. Then finally, our college name, Madanapalli Institute of Technology and Science, and so on. This is the first page. Similarly, this document contains 6 pages. So I have written in terms of 1, 2, 3, 5 pages. So where 2 pages are being combined together. So this is how beautifully you can make brochures in LaTeX software. Let me show you one more case study. The certificates that we are preparing for this workshop is also done in LaTeX. Let me just show you a sample. Just a sample document, a participant certificate. Just let me run and show you. There are some mistakes in this because the file is not available. Just a minute. Yeah, because this file is not available with me. That is a background file. So this is how the document looks like. This is how the certificate looks like if you prepare it in lab. Let me just go through all these things in this document. Just VSpace. Again, it starts with an article. It's basically an article of 12-point size. I am using different packages and different colors for the contents. Then the document starts here. The document starts with the 2 images, and that is our college image. And it is followed by the contents like Madanapalli Institute of Technology and accreditations and affiliations, everything. Then followed by 3 images because our college is accredited by NBA. It has NIRF ranking. We got A+ NAC. So the 3 images are being placed. These are the contents. Then we have I have written like a 5-day short-term course on. It is not yet finalized. A short-term course on emerging topics on instrumentation, followed by certificate of participation with a spacing of -0.5. It goes on like this. Even the color is gold and it is in calligraphy font. Then the remaining is in italics and it's a large font. This is to certify that. And so even the QR code which is present here is also a part of the LaTeX. So this part automatically generates the QR code based on your details. So this is not a limitation of the LaTeX. LaTeX has an unlimited potentiality. You can explore it. You can make too much professional documentation. in your perspective field. So with this, I will conclude my session because from yesterday and today, I have given an overview of what actually is LaTeX, but this is not a part of the patenting because this is a background for patent documentation, where the LaTeX and patent drafting will be covered by my friend, Mr. Sai Srinivas. That will be tomorrow. If you want to understand tomorrow's hands-on with the patent drafting, these basics should be mandatory because without these things, it is very difficult for the speaker to make you understand. So with this, let me conclude my talk. And if you have any queries, please ask. And 1 minute, sir. I will share a demo to you. You can do some hands-on practice from your side. As I said yesterday, no need to do in offline mode. There is a website called as overleaf.com, which I have shown yesterday. You can do your workshop. You can do your hands-on session practice there. Thank you.
Thank you so much, sir, for giving us a detailed description about how to use LaTeX and how to prepare documents. But this will be really helpful for us being a faculty to prepare some like research papers, writing some patents. This will really help us. And since we can't see any queries from the participant sites, so we can conclude here. So participants, if you miss anything, don't worry, we will be sending out the details, PPT and on-demand recording also when it will be available. Thank you, everyone. We appreciate you being here. Thanks again for joining us today, both in the first and second session. We will meet you tomorrow again at 10 a.m. Thank you, everyone. Thank you, my sir.
Thank you, sir.